Good morning. Welcome back. So, last class we finished with all the lab programs and we are done with C, that is chapter from 5 to 12, and then we have also covered complete data structures. Now, we'll be starting with a new chapter, that is chapter 2, Boolean Algebra. Boolean algebra, the weightage of this chapter is 9 marks. You will get one 2-mark question and two marks question and one 5-mark question. That is total of 9 marks, and it is a easy chapter. Students who don't like programming or they are confused with programming can concentrate on this better so that you will get all complete 9 marks. So Boolean algebra will be starting from today, and then we won't be doing programming over here. So in this chapter, that is the objectives of this chapter, we will learn concept of reasoning and logic, different logical operations. What are the different logical operations? And, or, and not. So different logical operation, logical expressions, Boolean postulates, use of De Morgan's theorems, understand various types of gates, that is basic gates, universal gates. We'll be doing different gates. Then different types of Boolean expressions, that is sum of product and product of sum expressions, difference between min terms and max terms, and simplification of Boolean expressions used in algebraic form, as well as using K-maps, wherein using K-maps is 100% 5-mark question. Every paper will have a K-map question wherein you have to simplify the Boolean expression using K-maps, and it's 100% question, so you need to learn that. So you will have two marker questions from this chapter and one 5-marker, wherein that 5-marker would be a K-map question. So we'll be starting with Boolean algebra. So what does it mean? An algebra that deals with binary numbers. What are binary numbers? 0 and 1 is binary number system. Base 2 is nothing but binary number system wherein you have two symbols 0 and 1, right? So algebra that deals with binary number system is called Boolean algebra. Originally it is also it is also called as switching algebra, which is a commonly asked 1-mark question. What is the other name of Boolean algebra? The other name of Boolean algebra is known as switching algebra. Originally known as a symbolic logic, this modern algebra uses a set of numbers 0 and 1. The operations are or, and not. That is union, intersection, and inversion. Boolean algebra is ideally suited to digital circuit analysis. So, Boolean algebra derives its name from the mathematician George Boole, who is considered as the father of symbolic logic. Instead of usual algebra of numbers, so what is the usual algebra? Wherein you have different numbers, right? So instead of usual algebra of numbers, Boolean algebra deals with truth values, true and false, wherein 0 is false and 1 is true. Okay? The purpose of this algebra was to solve the problems involved in non-practical applications, like involved in logical steps and their solutions. So, algebra had no practical applications until 1938, until Claude Shannon of Bell Telephone Laboratories used it to analyze telephone switching circuits. Because of this, engineers realized that the Boolean algebra could be applied for computer electronics. So now, today, as on today, it is the backbone of design and analysis of computers and digital circuits. Like, how is it applicable? You must be thinking that, right? So, computers use two value Boolean circuits for above reasons. Like, for example, for the following reasons, I can say the most common computer architectures use the sequence of Boolean values, right? What does it use? It uses a machine level language where it is a sequence of zeros and ones, like each one or each command, or I can say each character, whatever it can be, like anything in a computer is represented as a set of values like zeros and ones, right? Each one is called a bit. Like each 0 is a bit, 1 is also a bit, where 0 and 1 is a bit, and it's called, bit is nothing but binary digit. So the most common architectures, what do they use? Ordered sequence of Boolean values called bits of 32 or 64 values. When programming in machine code or assembly or certain other programming languages, wherein the programmers work with low level digital structure of data registers, wherein the data is stored in registers. Okay, these registers operate on voltages where 0 volts represent Boolean 0 and high represents 1. Such languages support both numeric operations as well as logical operations. What do you mean by numeric operations? Numeric means, like last time, yes, you have done arithmetic. What is that? Boolean, yeah, base to arithmetic. Then you have done subtraction, all that, right? In this context, numeric means that the computer treats the sequence of binary bits as a binary number based to number and executes arithmetic operations such as add, subtract, multiply or divide. We have done addition and subtraction in data representation chapter of class 11, right? And then logical refers to the Boolean logical expressions of disjunction, conjunction and negation, or and or not, between two sequence of bits in which each bit in one sequence is simply compared to the other bit. Yes, bit by bit is what? Bitwise. And you have done that, right? For and you will be using that truth tables also, wherein both are high, it is high, otherwise it's low. Wherein for an or, both are low, then it is low. Not is just a complement of it is, that is the 0 is 1, 1 is 0, right? So in which each bit is one sequence is simply compared to the counterpart in the other sequence. So programmers therefore has the option of working in and applying the rules of either numeric algebra or Boolean algebra as needed. The main difference here is in numeric algebra you have carry operations, wherein in the second it is not there. It is just how many high and how many low. Based on that, it will give you a true or a false value, right? The logic gates are the building, like it is very powerful in designing logic circuits used by the processor of computer system. So Boolean algebra nothing but deals with binary number system. And where is it used? It is a backbone of design and analysis of computer and digital circuits, right? Other digital circuits, it's either 1 or 0. And then it is very powerful in designing logic circuits used in the processor of computer system. The logic gates are the building blocks of all circuit in a computer. We'll be doing logic gates also, right? This is Boolean algebra and logic gates is a together chapter. The Boolean algebra, as we discussed, derives its name from the mathematician George Boole, who is also considered as a father of symbolic logic. So you will have this as a one marker. They can ask you who is the father of symbolic logic, or who is from where does Boolean algebra derives its name, and the other one is what is the other name of Boolean algebra. The other name of Boolean algebra is switching algebra. It is also called as switching algebra. So important definitions, like what are the important definitions in this? Please learn this so that it will help you in like two one marker questions, right? A variable used in Boolean algebra or Boolean equation can have only two values. Yes, a variable, like see, I say x plus y is equal to something or whatever. A variable used in Boolean algebra, x and y are variables, right? A variable used in Boolean algebra or Boolean equation can either have only two values. It will be either 0 or 1. X can take value 0 or x can take value 1. It cannot take any other values because Boolean is only two, like 0 or 1. The two values are 0 and 1. Either it can be 0 or it can be 1. A sequence which can be determined to be true or false are called logical statements or truth functions, and the result true or false is called truth values. We'll be writing truth tables also for each one, and you can write proof of many things using truth table or by substituting x is equal to 0 or x is equal to 1, or you can prove it algebraically also. A logic gate is or circuit is simply an electronic circuit which operates on one or more inputs to produce a single output. Like the output would be single, but the input can be one input, two or three more inputs. You can have more inputs, but then the output would be 1. That is a logic gate. Getting it? A logic gate is simply an electronic circuit which operates on two or more input signals to produce an output signal. There will be one output signal, but you can have one or more input signals to produce one output signal. That is nothing but a logic gate. Please go through this. Next is truth table. You would have done truth tables now. A truth table is nothing but it is a table which will show you all the possible values of inputs and their corresponding outputs. Like for example, x and y I need to have. X and y, x or y are the two things if I am doing. Then the different possible values would be, how many variables are there? 2, right? So 2 raised to number of variables 2 is 4. So the values can be 0, 0 when both x and y are 0. You can have x0, y1 and x1, y0 and both are 1. So you have 4 different variations or combinations. Then you need to write a truth table for that with a corresponding output. A truth table is a table whose columns are statements and whose rows are possible scenarios. Like all possible scenarios you give, it can be 0, 1, 1 and 1, 0. This is what I was trying to tell you. X, Y are two these things. Like here they have given R as the result. So 0, 0. X can be 0, X and Y can be 0. The result is low. Like 0, 1, 1, 0, 1, 1. This is a truth table of AND gate. Like you are using an AND wherein only when both are high then you will get a high, otherwise it's a 0. Next is logical operators. Again, we have done logical operators in C++ as well as we have done in last year also you have done. So it is the same logical operator wherein the truth table of the logical operators remains the same. There are three logical operators. Not is just the complement. X is x bar. If x is 0, x bar is 1. So 0, 1, 1 and 0. So not is that just the complement of that. Or is binary addition. Here I'm just giving you an introduction. We will do this all in detail. I will solve it and show it to you. So you just go listen to what I'm saying now. Or is binary addition. Or is binary addition and is binary multiplication. Addition is plus, multiplication is dot. And when both are true, if it will work when two or more inputs both are true, like everything has to be true for an and to be true, and or is true if one of that is true. These operators are now used in computer construction known as switching circuits. Now they are showing you the not operator. This is the symbol of not. They can ask you, it's a one marker question, the symbol of not. When I say symbol, you need to draw it like this only, and you need to write the input and the corresponding output. Without input output, you will not get marks for this. Not operator works on single variable or single input. What is that? By not operator, you get the complement. If x bar is inputted over here, then it would be x. Like x can take the value of 0, so x bar is 1. Just the complement or the opposite of that. And 1 and 0. This is the truth table of NOT gate, and this is the symbol of that NOT gate. Getting it? This is the symbol and this is the truth table. X, since there is only one input, either x can be 0 or it can be 1, because it takes only two values. You will not have more than two. It will be either 0 or 1. If x is 0, the x bar output would be 1, and if the input is 1, the output would be 0. It just complements the input. So x and x bar, whatever can be the value of x, it can be either 0 or it can be the 1. Please make a note of the symbol along with the diagram, along with the truth table basically. The next is OR operator. The OR gate should have two or more, minimum is two inputs or more input signals, but only one output signal. It will have only one output signal. You can say R is nothing but X plus Y. The output will be a logical addition of inputs. When I say logical, don't add, make it as arithmetic. So 1 plus 1 plus 1 in arithmetic, 3 is what? 1 1. Whereas in logic it remains 1 only, that is true. So either logical addition will say either it is 1 or 0. Whereas in arithmetic addition it will be 3. 1 1 you have to carry, borrow, all this. In subtraction borrow will be there, in addition carry will be there. All that happens in arithmetic addition, but here you are doing logical addition. Logical worked on this truth table. So what is the truth table? If all the inputs are low, then only the result would be low for a OR gate. Like all the inputs are low, like two or more, it should have minimum of two inputs, and then you can have two or more inputs and one output signal. So when I say logical plus is nothing but when all the inputs are low, then only the result would be low, otherwise it will be high, like 0 or. It is similar to or. If one of this is true also, it will be true. You use it in your programming also. You have done that. The OR gate, that is 2 pipes, which says that, yeah, how do I evaluate it? Individually I'll say whether each condition evaluates to 0 or 1. At least if one condition is true, it will be true. The operation performed by OR is called logical addition. Logical, please underline this. The symbol we use is plus, that is x plus y, or we can read it as x or y. X or y, the truth table is this. This you can write x plus y, put a circle on plus and write it. Or and this one is 0 0 1 0 0 is 0. Only when everything is 0 it will be 0, otherwise it will be high. If one of that is true also, it is high or true, I can say. And it performs, or operator performs logical addition. The next is AND. AND gate, we have two or more inputs and produces one. See, these diagrams, these symbols are very, very important. So what is it? When all the inputs are high, 1, then only it will be high. Otherwise, the output would be 0. In OR, what happens? All the inputs should be low, then only it will be low. Otherwise, if one of the input is high also, it becomes high. Whereas in AND, that is logical multiplication, you use dot to represent it, whereas logical addition, that is the OR operator, is plus symbol. The AND gate can have two or more inputs and produce one single output. Yeah, you can see in the diagram also, you have two inputs, that is x, y, and output is x dot y. So suppose x is 0 here, here y is 0, f result would be 0 because x dot y is 0. You can see the truth table here. Only when both x and y are high or 1, then only x dot y would be 1, otherwise it will be 0. The multiplication performed by AND operator is called logical multiplication, and the symbol used is dot, that is x dot y, or it can be x and y, but you make a practice of using dot and plus. Please make a note of this. The next is evaluation of Boolean expressions. Before that, let me go back. Not is nothing but the negation, like, so it is just the complement of that. 0 is 1, 1 is 0. It works on single variable input. That is, not operator operates on single variable, and operation performed by not is called complement. Like if it is x, it is x bar. So if x is 0, it is 1. Otherwise, if x is 1, the x bar, the result is 0, right? Because x can take only two values, that is 0 or 1 in Boolean algebra. This symbol is very important. Next is OR, which will perform logical addition. Logical addition, this is the symbol of OR gate, where R, this result would be nothing but x plus y. What is x plus y? Which is the result. Like x and y can have the combinations of, like you can write it in 4 different rows, where x is 0, y is 0, then x plus y, both are low, then only the logical addition will evaluate to 0. Otherwise, if one of that is true also, it will evaluate to a true value. You can see from the truth table over here. 0 and 0, both are false, then it is false. Otherwise, every time if one of them is true also, that is 0, 1, 1, 0 and 1, 1, here it will be true. This is the logic or operator, and this is the diagram, circuit diagram of that. The next is AND, wherein it is the logical multiplication. If again it will take two or more input signals, and it will produce you a one output signal. That is what is nothing but a logic gate, right? Which can take more than two or more signals, wherein the output, one, two or more signals, wherein the output would be only one signal. It will produce a single output signal. In OR gate, when all the inputs are high, that is everything should be 1, then only the result will be 1. That is the output will be 1, otherwise it will be 0. And it is represented by dot symbol and it is called logical multiplication. Either you can write it as x dot y or it can be read as x and y. Okay. Now we'll do evaluation of Boolean expressions using truth table. So you need to construct a truth table or you have to create a truth table with the following steps, and then they will give you an expression or they can give you an expression, and if they don't specify explicitly, like either with truth table or by induction wherein you give x is equal to 0 and x is equal to 1 and you prove that LHS is equal to RHS, or by using algebraical proof also they can ask, wherein you will be using theorems to get the like you need to prove something. Whereas how do I prove or evaluation of a Boolean expression? Evaluation is nothing but LHS. You need to prove LHS is equal to RHS by using truth tables. Like I will show you the example of one 2 variable one and one 3 variable truth table, and it is very easy you can do for the remaining. To create a truth table with the following steps. Step 1, determine the number of variables, like how many variables are there. Depending on that, the truth table will have that many rows. Like for example, if it is 2 variables, the 2 raised to 2, that is it will have 4 rows, and if it is 3 variable, it will be 2 raised to 3, that is it will have 8 rows. Fine. So you will know, like depending on the number of variables, the truth table will have that many rows, that is that many possible combinations of zeros and ones, right? List the variables of every combination of 1 and 0. You need to have that, and then you need to create a column for each term of the statement depending on the expression. I will take an expression and I will show you how exactly that it works. If two statements have the same truth values, then they are equivalent. That is, RHS is equal to LHS. Normally we will do RHS is equal to LHS. That is the proof, right? So we will do that. Evaluation of Boolean expression using truth table. For example, I have x bar or x dash is nothing but x and x dash, right? X is 0, then x dash should be 1, and if x is 1, x dash is 0. So x dash y dash plus x dash y is equal to x dash. You need to evaluate this Boolean expression using truth table. How many unknowns are there? How many variables are there? 2 variables you can see, that is x and y. So how many rows should I have? I need to have 2 raised to 2, that is 4 rows, right? 2 variables, I need to have 4 rows. And what are the different columns I need to have is x, y, x dash, y dash, x dash y, x dash dot y dash. That is logical multiplication. You are using and over there, and x dash dot y, again a logical multiplication, that is nothing but and operator is equal to x dash. So I should have totally, finally, whatever is the result of this column should be equal to the result. Like x dash column, that is the third column, and the last column should be same. Then only you can prove that LHS is equal to RHS, right? Please make a note of this. So anyway, you know how many variables, that is number of variables is equal to 2 number of rows in truth table is equal to 4. That is 2 raised to 2, right? So that many rows would be there in your truth table. You can find that many rows. 4 rows are there in your truth table, and then depending on the terms of your Boolean expressions, you will be having that many columns. What are the operations we are doing here? We are doing the logical AND operation, as well as we are doing the logical OR operation. OR is nothing but logical addition, and AND is nothing but logical multiplication. Since we are doing that, you need to find x dot y, and then you need to have an OR operation also. I will write you the truth table for the same, because based on that truth table only you will get the results over here. So, what is AND? That is dot. So, I will have x and y. So, how many columns would be there? How many rows would be there in my this thing? I need to have 4 rows because I have x and y, because AND gate is something which will take 2 or more inputs and it will give you one output. So, I will write a 2 input one. So, x and y, let that be the 2 inputs. So, insert table, I will insert the number of columns x and y and x dot y. Okay, and number of rows is 4 plus 1 heading 1. So, I will have 3 columns and 5 rows. Okay, so let this be x, then I have y, then I have x dot y, right? I do have x dot y. So this is the AND operation. X and y are 2 inputs and x dot y is the output, which would be one output, and this is an AND operation. It is also called as logical multiplication, and I am doing this very slowly because commerce students may find it difficult to understand. Please pay attention to this. What is x? X is, let me say, first value. X can take values 0 and 1, right? So let y also be 0. So x dot y would be 0, which is false or low. 1 is high, 0 is low. I can say true or false. Like both the inputs 0 and 0, that is x and y are false, x dot y also, or I can say x and y. You can say that also, or x dot y is also 0. The next one, I can have 1, 0 and this is 1. So, you have different combinations of that. So, there will be 4 combinations of that possible here. 0 dot 1 in an AND, both should be high to get an high output, otherwise it will be low. So, it will be 0, and now I can have 1, 0. So, again this will also be 0, and another one is both are high, right? Is 1. So you can see that according to the truth table, that is the dot operation or the AND x dot y, x and y are 2 inputs and x dot y is the output for a logical multiplication or logical AND operation. When both are 0 or low or false, the output x dot y is 0. 0, 1 also is 0, 1, 0 is also 0, and 1, 1. That is, all the inputs should be high or true, then only the result would be true, otherwise it is false. That is, it will give raised to a 0. So this is for AND, right? Another operation, what do we have over here? The other operation we have here is, what do we have here is OR, right? You have a plus operation. This is dot, and then I do have a plus operation here. So what is plus is nothing but logical addition or logical OR operation, or is nothing but addition, logical addition, and dot is nothing but multiplication, which is logical multiplication or the AND operation. So let me write it. I will write the truth table for OR also. Of OR, which is nothing but plus, right? So I need to insert a table with 3 columns and 5 rows. Okay, this is X and this is Y. This is X plus, X plus Y. So what do the first one? 0, 0 is 0. Next is 0, 1 is 1. I have 1, 0 is also 1, and then I have 1 and 1 is also 1. So what are the different values we are seeing here? We are seeing, you can see there, x and y, x plus y, which is nothing but logical addition or the OR operation. If both the inputs are low, then only it is low, or false, it is 0. Otherwise, if one of them is true also, it is true. So this is the truth table for it. Getting it? Yeah? I would want you to make a note of the truth table. They'll ask you the symbol, the truth table of the different gates, whether it's AND or NOT. NOT will have only one input and one output. Now you need to follow the same truth table when you are doing any particular dot or plus operation. And another NOT also we are doing here, because x bar, you do have x bar. X bar is nothing but the complement of it. What is x? X is 0, x bar is 1. If x is 1, x bar would be 0. That is the NOT operation. Fine. So let me write here, let me fill the table over here. So I will say 0. Y would also be the different possible values of different possible values. Let me say this is also 0, and then again 0. Let me say 1, 1, 0, 1 and 1. So we have taken all the possible combinations of x and y. So x and y will take only 1 or 0. Only two values it will take. So I can say 0, 0, 0, 1, 1, 0, 1, 1. So we have got all the combinations which is possible. Now I have a column for x bar. So what is x bar will come? If x is 0, x bar would be 1, the complement. So x is over here 0, so x bar is 1. Again x is 0, what is the value of x bar then? 1. And what is the x is 1, x bar should be 0. And x is again 1, x bar is 0. Hopefully you have understood this. See, x and x bar. X is 0, x bar. It's just the complement of it. If it is 1, it will be 0. It is 0, it will be 1. And then I do have one more y bar. So what is y over here? Y is over here 0. So y bar should be 1. And y is 1 over here. So y bar should be 0. And then y bar is 0 over here. So sorry, y is 0 over here, y bar should be 1, and y is 1 over here, so y bar would be 0. You can see that y is 0, y bar is 1, y is 1, y bar is 0, and y is 0, y bar is 1, and y is 1, y bar is 0. It's just the complement of it. Hopefully you're getting it. Now I do have x bar dot y bar. What am I doing here? I am doing the AND operation or the multiplication, logical multiplication operation. So you need to follow the truth table of AND, right? So what is x bar and y bar? X bar dot y bar. What is x bar? 1. Y bar also is 1. So when both are high or true, the result would be true. Then x bar is 1, y bar is 0. So if one of them is low also, the result would be 0 according to the AND, right? Truth table we wrote. So here 0, 1 again would be 0 because you have a low here. 0 and 0 is also 0, right? And now we will do the other one. X bar dot y. We did x bar dot y bar. Now we will be doing x bar and y. That is this column and this column, right? This is x bar and this is y. So what is x bar? It is 1 and y is 0. Y dot 1 dot 0 is 0. Then 1 dot 1 because x bar is 1, y is also 1 will be 1, and again 0 dot 0 that is 0, and here also I can see 1 dot 0 that is x bar is 0 and y is 1 which would give raised to 0, right? And now we are going to the last column, that is x bar dot y bar plus x bar dot y. So here you are going to do the addition, that is logical addition or the OR operation. So what I am going to do? X bar dot y bar plus x bar dot y. So this is x bar dot y bar and this is x bar dot y. So I need to consider these two columns. 1 plus 0 is 1, yes, because one of them is high also, the output would be high in case of OR. We saw the truth table also. 0, 1 is also 1, and then 0 and 0 both are low, it is 0. Here also it is 0 and 0 both are low, it is 0. So we have come to the end of this. Now can you say that the Boolean expression is true, like x bar y bar plus x bar y? So this is the column which says that x bar y bar x bar y. This column, yeah, and then I do have the other one is equal to x bar. So which is the column over here? This one, yeah, equal to x bar. Can you see it is same 1 1 0 0 1 1 0 0, since both are same, that is why hence the expression it is proved, right? So this is how you evaluate an expression using truth table. Boolean expression using truth table. This one is for a two variable one. Please have a look. Then we will do an example for a 3 variable one. So I will do one example for 2 variable and one example for 3 variable Boolean expression evaluation with truth table. As it is very easy, I don't want to solve more. I will be solving more problems on um, K-maps. I will do many, all the exam asked ones. Along with that, I will do some more example problems also, and a canonical form again, which is very important. That also I'll solve more. Since this is very easy, I will do one for 2 variable and one for 3 variable ones. Please have a look. Now we'll do the 3 variable one. So what are the 3 variables we have? X, Y and Z. So I need to, how many rows I would need? 2 raised to 3, that is 8 rows. Number of variables is 3 and I would need 8 rows, that is 2 raised to 3, 8 rows in my truth table. And how many columns I would need? I would need 8 columns, right? One for X, one for Y, one for Z, another for X plus Y plus Z, and then X dot Y plus Z, then X dot Y and X dot Z. Then I do have to write X dot Y plus X dot Z. So these are the column headings I would be having. So 8 columns and 8 rows and 1 for the header. So totally I will have 9 rows and 8 columns in my table for this, right? So insert table, number of columns is 8 and 9 rows. That is 2 raised to 3 is 8 and 1 is for the heading like X, Y, Z. That. So I will say X, Y, Z. I will not be having X bar, Y bar and Z bar because that is not there anywhere in the expression. So that is why I will not be using that. Y plus Z, right? And then this Y plus Z. Then what do I have? I need to write X dot Y plus Z, and the next one would be X dot Y, or I can write this in the end. Okay, let this be X dot Y and let this be X dot Z, and then X dot Y plus Z. The last one is X dot Y plus X dot Z. So we are clear here. X, Y, Z, X plus Z, Y plus Z, X dot Y, X dot Z, X dot Y plus Z, and the last one is X dot Y plus X dot Z. So let me write down first the different combinations. So the 0, 0, 0. I can have 0, 0, 1, 0, 1, 0, 0, next, 0, I can have 1, I can have 1 over here, and then 1, next is 0, 0, 1, 0, 1, 1, 1, 0, I can have 1, 1, 1. So can I see all the combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0, 1, then 1, 1, 0, 1, 1, 1. These are the different possible combinations of x, y and z. After that, I need to do y plus z. Whenever I say plus, it is y or z, or it is logical addition. In logical addition, if one of the input is true also, the output would be true. So here x, y, z, all the three are 0. So the output is 0. Here it is 1 because I have z as high. Then I do have the other one. What is that? 0, 0, 1. Again should be 0, right? It is 1, right? And then I do have 0, 1, 1, which is 1. 1, 0, 0 is 1. So all the remaining ones would be 1 because it is, sorry, y plus z I'm doing. What am I doing over here? Sorry. Okay, this is true, this is true. 0. Here it is 0. Sorry. I checked all the three. So y plus z is, this is 0. All the others like 0 and y is 0, z is 0, 0. 0, 1 is 1, 1, 0 is 1, 1, 1 is 1, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is also 1. Since I am doing an OR operation here, in OR, any one of that is high also or true also, it will be high. After that, I have an AND operation. In AND, all the inputs should be true, then only it will be true. So, x dot y, 0 dot 0 is 0, 0, 0 again is 0, 0, 1 is 0, 0, 1 is again 0, 1, 0 is 0, 1, 0 again is 0, 1, 1 is 1, and again 1, 1 is 1. You can have a look over here, right? This is an AND operation what we did. Here we did OR. Then I do have x dot z. That is the first and the third column. 0, 0 is 0. 0 and 1 is 0. 0 and 0 is again 0. 0 and 1 is 0. 1 and 0 is 0. I have 1 and 1 as 1. And then 1 and 0 again as 0. And 1 and 1 as 1. So you have x dot z like this, right? After that, I have x dot y plus z. So I have y plus z here, and this is the x1. So you are doing AND operation over here, right? You will be doing logical AND operation or logical multiplication over here. So x is 0, y plus z is 0. Then I have x is 0, y plus z is 1, again a 0. X is 0, y plus z is again 1, which is 0. X is 0, y plus z is 1, 0. Then x is 1, y plus z is 0, it's a 0. X is 1 and y plus z is also 1, so it's a 1. X is 1, y plus z is also 1, it's 1. Here it is 1. So you have the values over here, and then I need to do this. So what is x dot y and x dot z? These two columns I need to do the addition operation, right? I need to do the addition operation of the two columns. 0 plus 0 is 0. 0 plus 0 is again 0. 0 plus 0 is 0. 0. 0 plus 0 is 0. And 0 plus 1. In or one of them is high also, the output would be high. So I have 1 0 is also equivalent to 1. 1 1 is also 1. So you can see the last two columns, they are same. So you can see LHS is equal to RHS. Can you just please go through this once? This is how you need to construct, write a truth table and prove that LHS is equal to RHS. Yeah. So next, hopefully you have understood this. In tomorrow's class, we'll continue with Boolean Algebra. Please write down the homework question. Please write the proof using truth table. Fine. This is your homework question. So hopefully you've understood this. We'll continue with the chapter tomorrow. Take care. Stay safe. See you tomorrow. Bye-bye.